Hey guys, we are going to do an extra day of exponential word problems just because we've learned 4 formulas over the last 2 days, and we want to make sure that formulas are pretty easy to use. You just have to make sure that you know, number one, what formula to use, what goes in for the variables in that formula, how to type it into your calculator, and how to round. So we're just going to practice those 4 things today. All right, so here's the first question. It says Bill puts $1,000 into an account to use for his vacation fund. The account grows continuously. There's that word. Okay, so notice they didn't say compounded, but to grow continuously is still that formula. Okay, at a rate of 4.28%, how much will Bill have in his vacation fund after 4 years? Okay, so hopefully, guys, that we know that the continuously word means to use a specific formula, and that formula is A of t equals P e to the RT. Okay, remember, if you want continuously great looking hair, you should use Pert shampoo. Well, if you want to compound continuously, or if something's growing continuously, we will use that Pert formula. Okay, in that formula are our variables of A of t, P. Remember, E is in our calculator. It is a specific number already, 2.718. Okay, and then our R value and our T value. Okay. Bill put $1,000 into an account, and therefore, guys, that is the principal. What he is putting in is his initial amount. Okay. Our rate, guys, is going to be 0.0428. And his time is 4 years, and we're trying to figure out how much he's getting out. All right. So all we have to do is go ahead and write it down. Plug it in. All right, so that's what our formula should look like after we plug in. Again, guys, it doesn't matter if you call it A of t or A of 4 or Y equals, all right? Go ahead and grab your calculator and type that rate in. Remember, if you have the older calculator, that your exponent will need to be in one big set of parentheses indicated by these. Okay, if you have the newer calculator that gives you that little exponent dotted box, then you are fine without the parentheses, okay? And your calculator should spit you out $1,186 and 0.7280 ... Okay, I don't believe they gave me a rounding direction in here. However, this is money, and so money always gets rounded if there isn't a direction. To the nearest hundredth, which would be this 2, but look next door, he sees an 8, the 2 is going to turn into a 3. Okay, and so we're going to have $1,186.73. Okay, all right, number 2. If at the end of 2 years, a savings account has a balance of, and the interest rate is compounded monthly, that tells us to use our other formula, okay, at 3.2%, then what is the original amount deposited 2 years ago to the nearest dollar? There's our rounding directions. Okay. So this one's a little bit different. In fact, we've never solved one like this, where it's talking about what was the original amount given the final amount. But a formula is a lot of times just plugging and chugging along. So let's see what happens. But I did recognize that we're using a different formula. This is our A of t. Oops. A of t equals P 1 plus R over N raised to the NT. Okay, so because it says monthly, okay, our N value is going to be 12. Okay. All right, so here we go. So we got A of t in there. We have P. We have R, N, and T. And by that monthly, we already know that N is 12. Okay. We know our rate is 0.032. 2 years would be our time. And we have to be careful because it's saying that we want to know the original amount deposited. So we don't know our principal. We don't know what we put in 2 years ago, but eventually the final amount came out to be $1,172.60. And that's a little bit different, all right? But let's see what happens. So we'll end up with 1,172.260 equal to, I'm going to keep that as P, in parentheses 1 plus 0.032 divided by 12, and then raised to the 12 times 2. Usually like to write an X, like a multiplication X instead of a point, so it doesn't look like 12.2. Okay. All right, so we can't really type all of that in, but we can type most of it in. I'm going to leave this here because I don't think I can do anything with it. Okay. However, I do believe I can get one single number for all that. Okay. Because that's in parentheses, so that follows PEMDAS to be done first, which is fine. Raised to an exponent, X would be done next, and then multiplication by the P would be done third. And so I think it will be all right if we type all of that in. So go ahead and type it in. And we should end up with 1.066001591. Okay, so remember that P is being multiplied by that number. There's multiplication in between that P and that number. And so we're going to go ahead and undo that multiplication by dividing. Notice I'm going to do that dot, dot, dot. Remember, that means I'm not rounding the number. I'm just not writing it on my paper. I'm still going to use the full decimal when I divide those two numbers in my calculator. Okay. And we should end up with P equals 1099.99835 dot, dot, dot. Okay. And because they said rounding directions of nearest dollar, that's going to be this 9 spot, but looking at that 9 spot is going to round it up. Okay. And then that 9 is going to round that 9. Who's going to round that 9? Who's going to round the 0 to a 1? Okay. And you know, these aren't everybody's favorite to round like this, and some people are fine with it, but it is going to be $1,100. Okay, and so that's the amount of money 2 years ago before it grew to $1,172. Okay. All right, next question. Number 3 is talking about an animal population is dying. Oops, dying out. I want it to be highlighter, dying out. That's decreasing. There's a decrease, there's another word, in this number of animals by 8% per year. Okay. In 7 years, there will be 80 of this animal left. What is the current population of this animal today? All right, I did not see any compound. I did not say continuous. I didn't say half-life. So I am going to go ahead and use the first formula we learned, which is y equals ab to the x. So my variables are y, a, b, and x. Okay. 8% is going, okay, so remember in this one, guys, that yeah, b value has to be 1 plus your rate or 1 minus your rate, okay? Because this is decreasing or dying out, this is going to be 1 minus 0.08. 7 years will be our time frame, which is x. There will be 80 animals left. What is the current population of this animal today? So 80 animals left would be your final amount, which is y, and our initial amount is our a value, which we don't know. Okay, I think we're ready to go. This one's a little bit different again than we are used to, but I think it's similar to the question we just got done. So we're going to put in 80 for y. Our a value we don't know, so I'm going to keep it a. In parentheses will be 1 minus 0.08, which is 0.92. Which is less than 1, which is why this is going to decay, okay? And then raised to the 7th power. So what I'm going to do is I'm going to go ahead and type in 0.92 raised to the 7th power. And we're going to get 0.557846 ... Okay. Remember, guys, that A value is being multiplied by that 0.92 raised to the 7th. So to undo the multiplication, we're going to go ahead and divide by that number. Again, guys, my ... shows you I'm still using the full decimal in my calculator. I'm just not writing down on my paper. Okay. And when we do the dividing there, A should come out to equal 143.4085 ... Okay. I don't believe there were any rounding directions in this question. However, this question is about animals. Okay. And so with animals, we are not going to have a decimal of an animal. And so we're going to round to the nearest whole animal because we like our animals whole. And so we're going to say 143 animals. Okay, just like with money, we don't like all those decimals. We like to the nearest cent. With animals or humans or things that cannot be a partial of, we'll round to standard rounding rules. Okay. All right, number 4 talks about Megan, and she is depositing $8,000 into an account paying 4.3% interest compounded weekly. Okay. To the nearest $100. There's our rounding directions. How much will be in the account after 4 years? All right, so because they said compounded weekly refers to the number n of equal to 52, because there's 52 weeks in a year, and therefore that tells me I will be using our formula of A of t equals P in parentheses 1 plus R over n raised to the nt, where that n value for weekly, 52 weeks in a year. Okay. So we'll go ahead and write our other variables down. And we already said n is, 52. 52. Okay. Our P, guys, is what we're depositing or putting in, which is $8,000. Okay. Our R is 0.0435. And our T is 4. Okay. We want to know how much will be in the account after 4 years. What's our final amount? Okay. All right. So if we plug it in, we could say A of T equals 8,000, 1 plus 0.0435 divided by our n, which is 52, raised to the 52 times 4. Okay. Again, if you have one of the older calculators, your 52 times 4 either needs to be multiplied first or it needs to be in one big set of parentheses. You type it all in, and we should end up with $9,519, 8.752051. Okay. They did say nearest 100, and we have to be careful with this one, guys, because nearest 100th with a TH is different than nearest 100. Okay, 100 is this spot with the 5 looking next door. Okay, 100th would be the other 5 down here. Okay, after the 7 there. So be very careful. 100th with the TH referred to decimal places. Okay, no TH, it refers to the left side of the decimal. Okay. And we're going to go ahead and say A of T equals, that's $9,500. All right. So basically you're looking at as 519 is closer to 500 than 600. Okay. All right, next one, number 5, talks about a radioactive substance has a half-life. Okay. There's your keywords. Actually, I should do that in my other color because that half-life tells me my formula to use. Okay. It is also part of what that 70 is. Okay. It says we have 41 pounds of the substance was found in a container. How much to the nearest pound, there's your rounding directions, would be left over 20 months. Okay. So our half-life formula is A of T equals A sub 0 0.5 raised to the T divided by H. Okay. We're going to go ahead and say A of t, A sub 0, T, and H. Okay. All right, so it says a radioactive substance has a half-life of 70 months. So our H is our 70 months. I like to put the label there so that we can double check that our time periods are in the same units. Okay? It says 41 pounds of the substance was found. So that's our initial amount, 41 pounds. Okay? And how much would be left over? 20 months. So 20 months is our time. And 70 months is our half-life time, okay? And we're trying to figure out our final amount of the substance. So we're gonna go ahead and say A of t equals 41.5 raised to the 20 divided by 70. Grab your calculator, type it in, okay? Again, older calculators have to have that 20 divided by 70 in one giant set of parentheses. Okay? You should get 33.63374, dot, dot, dot. Rounding directions are up in yellow. They said nearest pound, which would be this 3, but look next door, and that's going to round the 3 up to a 34 pounds. And that's how much of the substance would be left. Okay. All right. One last one on this side. Stuffed animals were a strange craze in the 90s. Kind of a strange problem. A cat stuffed animal with white paws sold for $6 in 1997. In 2015, the cat will sell for $1,015. Okay, so we got $6 in 97, 2015, 1015. Okay, I think they're referring to Thai Beanie Babies in this question, just so you guys know. Determine the percent rate of growth for these stuffed animals to the nearest hundredth. So there's our rounding directions. Okay. And now we got to figure out our formula. If you guys notice, we did not read compounded. We did not read compounded continuously. We did not read half-life. So this is the first formula that we learned, which is y equals AB to the x. And remember, guys, that this is the formula where B is 1 plus R or 1 minus R. All right, so our initial amount of the cat, I would say, is $6, and the final amount is $1,015. Our B value, I'm going to say that price grew, and so I'm going to say is 1 plus, but we don't know the rate. In fact, that's what we're solving for. And then our X is our time frame, so we need to figure out the difference between 2015 and 1997, and hopefully you guys know that that is 18 years. Okay. And we're going to go ahead and plug them in. So we're going to go ahead and say 1015 is equal to 6, in parentheses is 1 plus R raised to the 18. Okay. And this is one of those ones where we're working backwards, where we have to free out that R that's in those parentheses raised to the exponent. And hopefully you guys remember that the exponent and what it is living on, called the base, needs to be isolated before we get rid of that 18 by using the reciprocal power. Okay. So we're going to go ahead and divide by 6 to get that red highlighted stuff by itself. Okay. And that's going to give you 169.166 dot, dot, dot. Okay. Now, guys, we are going to go ahead and use our reciprocal power to get rid of that 18. But we have to do it to both sides. Again, guys, when those two exponents are multiplied together, they give you 1. And 1 minus R raised to the first power is just 1 minus R. I'm sorry, 1 plus R. And when I raise it to the 1/18th on the other side, I end up with 1.329827 dot, dot, dot. Okay. I'm solving for R, so I need to subtract the 1. And I would end up with R equals 0.329827 dot, dot, dot. Remember that because this is a rate, it needs to get converted into a percent first. So it's 32.9827 dot, dot, dot percent now. Okay. And now we can go ahead and round it to the nearest hundredth. Hundredth would be the 8th spot, but look next door, 2's not going to move in. And so we're going to go ahead and say that our R value is equal to 32.98%. And there it is. All right, we got a couple more questions on the backside, and I'll see you guys in the next video.